Okay, this is 3 questions, your last review before your big exam, which everybody's excited about, on Chapter 10. So these are 3 questions that have to do with each chapter. The first question here is about 10.1 on inscribed and central angles, the relationship between the two. The second question is about perpendicular bisectors to chords and the properties they have. And the third question is about lines that are tangent to circles and the properties they have. So those are the 3 main concepts in Chapter 10. So the first question gives you this circle that looks incredibly confusing and asks you to define the values of x and y, or angle ACB, which is x, and angle ADB, which is y. So I'm going to use my highlighter to make it a little bit easier to see. So if you have a test, it's probably best that you do that as well. So the first thing I'm going to do is I'm going to define the central angle that 64 is. So AFB is a central angle because A and B are connected to the middle, forming a 64-degree angle. Now remember, if A and B are connected to any other point outside of the arc here, outside of this arc, they will create an inscribed angle to that central. So A and B are indeed connected to another point, and that point is x. So since A and B are connected to the middle for 64, and A and B are connected to C for x, that makes x an inscribed angle to 64, or 32 degrees. Likewise, if I take my highlighter again and connect A and B down here to D, I have another inscribed angle that is the exact same situation as the first one. So A and B are connected in the middle for 64, A and B are connected to Y, which makes Y, again, 32 degrees. And like always, this piece of information, this central angle of EFD of 60 degrees, was superfluous information because E and D are not connected to any other point, meaning there is no inscribed angles to that 60-degree central angle, and therefore is not necessary for this particular question. In the second question, you're given the following information. You said FG is the diameter, and it's 12 meters, and chord AB is 10 meters long. And the only other piece of information that you see here that doesn't look like a piece of information is this 90-degree angle, which means really AB, chord AB, I can put chord here, chord AB is bisected by the radius at point E. And what that fancy sentence means is that the radius cuts chord AB perpendicularly. And because that is true, what we learned in 10.2 is if it's cutting it at 90-degree angles or perpendicularly, then it cuts the chord exactly into 2 equal parts. So before I start my question, I can actually write that down. I'll delete this arrow because it's kind of off-putting. I think if I... There we go. Okay. So now we can start to figure out all of our information. So FC, I'll use my highlighter for that. FC is this distance right here. That's the first question. What is the length of that? Well, it's actually a radius. And since the diameter of the circle, or the whole red line, is 12, that means that FC is half of the diameter, which makes it 6 meters long. Okay? So the first question is, do you acknowledge that FC is a radius, and if the diameter is 12, it's half of that? That's easy. The second question says, what is the length of AE? Which I'll highlight in yellow here. What is the length of this? Well, since the chord itself, right up here, was defined as being 10 meters long, and since it was cut perpendicularly by the radius, that makes the section of AE half of the chord's length itself, which will mean that that chord, or that section highlighted in yellow, will be 5 meters long, or half of the chord's length. So far we got 2 points out of the 4, and they weren't very difficult at all. The third question says, what is the length of CE? And here we're getting into slightly more difficult. I'll use green for this one. What is the length of this particular part right here? And in order to solve that, I think from our experience, we know that we need, if we don't know the distance at all, we know that we probably have to draw a right triangle, which we can right here, and I will draw it in red. And I will take that red triangle and I will shift it over here. I will put my 90-degree symbol here, and I will try and figure out 2 of the sides based on the information. Well, this distance here from point C to A, which is not There's no line there at all. If I was to draw that dotted line, I realize I drew a radius. And since I know the diameter to be 12 and the radius to be 6, then this hypotenuse that I've just drawn in my right triangle will be 6 meters. This distance here we've already defined as well. That distance there is half the chord, or AE, which is 5 meters. And this distance here is unknown, and it's really x. So once I've redrawn my right triangle, I realize it's just a simple Pythagoras question. Slap our squares on there. Inside each of those squares, put our area, 36, 25. And remember, the area of the squares attached to the legs will equal the area of the square attached to the hypotenuse. So 25 plus what is 36? The answer is 11. So therefore, the length of x will be, or the length of CE will be the square root of 11. Or if I take my calculator, should be 3 point something. Square root of 11, 3.3, approximately 3.3 meters long. So that's the answer to the third part. CE is 3.3. And the last question it asks, what is the length of, I'll use purple for this one. What is the length of ED, or this part here? And since the whole thing right here, that whole length that I just circled, is really a radius, and the radius, according to what we calculated, is 6 meters, and this part here is 3.3, then 6 meters take away 3.3 meters will be the remainder of that radius, which makes it 2.7 meters. And the answer for ED is 2.7. Okay? So that would be a question you will probably most definitely see on your test. Very basic, nothing very complex, but it does make you, force you to see the relationship between a perpendicular bisector, chord lengths, and defining radiuses and diameters that maybe don't exist on the actual picture itself. And the final question from 10.3 on tangent lines. It says EF is the diameter. So that red line is the diameter, and again, just like the last question, is 12 meters long. And AC is tangent to the circle at point B. So right away, before I go any further, because it says this, what I recommend you always do when you see that sentence is you take your pen and you just put that in, because that's really what that sentence means. And the last thing it says, AC is 18 meters. So the entire line that's tangent is 18 meters, and this part of that 18 meter line is 5 meters. Okay, so we have a lot of information there. So if EF is the diameter, then I know that DB, this line right here, is a radius. This line right here is a radius, which means I know it's half of the diameter. So I'm going to put 6 meters right there, because I know that the diameter is 12, so the radius is 6. I am also going to say that if this whole line AC is 18 meters and this is 5 meters, then BC, this point from right here to here, must be the remainder of that 18, which is 13 meters. Okay? So I haven't really done any math yet. I've done a little bit of adding and subtracting, but basically it's just been all basic, easy stuff. So BC is 13 meters. And BD is 6 meters, and I got that only from knowing the radius and knowing that if AC is 18 meters and the part of that 18 meters is 5, then the remainder of that 18 meters must be 13. So I got the first two parts of that question without doing any real complicated math. The next part says, how long is DG? That little green squiggly line right there. And that's easy because all it is, it's a radius. And if this is 6 meters, then an identical radius put somewhere else is also going to be 6 meters. And three of the 5 questions, I haven't done very much math at all, just basic logic. And the next part says, how long is DC? So I'm going to continue this all the way from D to C. How long is that line there? How long is DC? So really, if I look right here and I trace it in blue, well, that's green. That's not blue at all. If I trace it in blue, that's a right triangle, and I'll bring it right up here. This is 6, this is 13, and this is X. Slap my sides on there, grab a red marker. The area of this square would be 36, the area of this square would be 169, and the area of that one would be the sum of those two, which is 205, I think. Is that right? So the area of the two squares attached to the legs of a right triangle equal to the area of the square attached to the hypotenuse, making that 205. And therefore, the length of this entire line right here, or DC, is going to be the square root of 205, or approximately, is it 14.3 really? Oh, I wouldn't have guessed that. 14.3 meters. Okay, so now we have 4 of the 5 questions done, and our last part is, how long is it from here to here? How long is this distance here? Okay, and that might seem complicated, but it's not really. Since we know the whole distance of that line is 14.3, and I know the distance of here to here is a radius of 6, then 14.3, the whole length, take away the 6-meter radius, will leave me with 8.3 meters, which means the distance from here to here is the remainder of the 14.3 minus the radius, or 8.3 meters.